All right, so I have posted homework 4, okay? And so this is available. I normally give you like a week to get it done, with your homework done. I've chosen to give you a few extra days, okay? So rather than making, I was originally thinking of making it due Friday of next week, but I'm gonna make it due Monday of week 7, okay? Um, but please start working on it before Friday of next week, okay? So don't think of this like, okay, I'll just take, I know you guys have midterms and stuff, and I don't want you to just say like, okay, I'm gonna just wait for week 6 to be over and then I'll get started on this, over the weekend. I think you're gonna run into trouble if you do that, okay? You'll probably run into trouble as soon as you start it, to be honest. And so basically, the assignment is you had an assignment where you programmed chutes and ladders. Okay, this one you're going to program Monopoly. Okay, but it's just the board movement of Monopoly. Okay, you're not going to be buying, trading, and selling properties or charging rent or anything like that. There's no money to worry about. Just the board movement, okay? And there's no decision making to be done, okay? You don't have to decide whether you should buy the railroad or not. You just move. So you just roll the dice and you move, okay? But there's a bunch of little rules about movement, right? Like sometimes you roll doubles and you go again. Sometimes you land on a certain space and you draw a card and it tells you to move somewhere else. Sometimes you land on this space that sends you straight to jail. So there's different rules there. And for this assignment, I'm requiring that you use an R6 class object, okay? That you're going to design the object class for the player there. I've provided some code that will get you started as far as like the chance card deck, the community chest deck, the labels of the board spaces, and things like that. But yeah, you're gonna have to develop your R6 class object, and then also there's pretty much two things you're gonna work on. One is your definition of the player, and then the other is the function take turn. Okay. Now I strongly recommend that first you read through all the instructions. Okay. Number one, read the instructions. And then number 2 is before you just start coding up, think, okay? Think and write down some ideas on paper on how you're gonna achieve some of this stuff, okay? When you make your R6 class object for the player, you're gonna wanna add different methods. I think right now I have one method, which is move forward this many spaces, okay? That's fine. I would say I'm of the philosophy that your methods should be very simple. The method, when you call a method, it should be very clear what it's going to do, right? So, for example, you might want to create a method called go to jail, okay? Because there are several ways a player can go to jail. If they roll dice doubles 3 times a row, they go to jail. If they land on a certain space, they go to jail. If they draw a certain card, they go to jail. And rather than having to figuring out what is the code that I need to write for going to jail and then copying and pasting that in all of these different scenarios, just create a method called go to jail. And then anytime something triggers that, you just call the method go to jail. Go to jail is going to send the player to this position on the board. It's going to reset this and these things and stuff like that. You're going to want to add different fields to your R6 class. One of those fields will probably be in jail. Is the player in jail? Yes or no, okay? Or true or false. Because some turns the player starts off in jail, other turns they're not in jail. Sometimes they start off not in jail and then they go into jail. Sometimes they start in jail and they get out of jail. And you're going to want to have something that keeps track of that. So if you grew up in the United States, you've probably certainly played Monopoly at some point in your life, maybe at a family gathering. If you did not play Monopoly even though you grew up in the U.S.? Huh? Okay. If you did not grow up in the U.S., then the likelihood of you playing Monopoly is much lower, okay? Monopoly is kind of classic capitalist real estate tycoon game, okay? It was actually, it's a funny story, I don't know why I'm telling you this, but it was actually designed as kind of this commentary on how the rich get richer and oppress the poor, because that's exactly what happens in the game. But it turns out that that people enjoyed it. It just revealed the nature of the human soul, that that people had fun becoming the rich tycoon and making all of the other players suffer. So anyway, so that's what you have. But anyway, if you've ever played, the situation of, you plan the game and then you have to pause the game in the middle because it's dinner time and you have to put the game away, and you say, wow, we're only halfway through and we want to continue this. In order to continue the game, you'd have to write down certain things, like the dog is on this spot on the board, the player had this much money, the player is in jail, and things like that. And if you think about the different things you had to keep track of, those are probably going to be good fields to add into your player class definition. Okay, obviously you don't have to keep track of the money. That's not part of the assignment, but you have that. Okay. So anyway, get started on that now rather than later. Okay, and I'm happy to answer questions about it during office hours next week, but we have that. Also, I will post an old midterm exam on CCLE probably tonight, and you can start studying from that. Study the quizzes that you have during discussion section, and yeah, we'll have a midterm next week, Wednesday. Yeah.
What's the format?
What's the format? It's pen and paper. No, is that funny? I don't know. It's pen and paper, no computer. Okay, so you don't have a computer in front of you. And most of the questions will be, here's some code, what is this going to output? Okay, and it's going to be like, there's going to be a handful of edge cases there, right? It's not going to be all edge cases, but there's going to be enough where it's going to be annoying. Okay, where it's going to be kind of like, here's some code that probably, if you were a good programmer, you should never write, but somebody has written it and it's causing problems or whatever. What is this going to output, right? And it's important because when you program, I guess I'm trying to defend this format of the exam. When you program, you have to be able to write good code, but you also have to be able to read bad code, okay? Because a lot of times you need to fix problems because somebody did something not optimal. And it might have been you who didn't know any better 6 months ago, right? So, and so it's very important that, when you see a function, you know exactly what it's going to output, what type of data it's going to output, because basically what it outputs, what type it outputs is going to affect what things you can do to it. So a lot of it's going to be that. There might be a couple sections where I have you write a few lines of code, okay? But if I have you write code, it's going to be no more than like 5 lines of code, okay? It's not going to be like write out your Chutes and Ladders game or something, okay? I'm not going to have you do that, all right? It'll be like, write a small function that will perform this small task or something, okay? And then again, there will be regular expressions, but it's just going to be, but I will include the regular expression cheat sheet that I've linked, so you can at least do that, right? But that cheat sheet only uses single slashes, single backslashes. In R, we have to use double backslashes and stuff. But, I don't know, and if you do bad on the midterm, like, it sucks, okay? But it doesn't mean you're a bad programmer or bad, right? It just means these questions weren't your cup of tea, okay? And it's okay, we're trying to develop you completely. No, not completely, right? That's too likely. You have to develop your emotional baggage and stuff. But no, just your ability to both read through code and understand what it's going to output, but also your ability to write code. And that's kind of what the test and the homeworks try to do. It's a tough task, and I don't know if it's even possible. All right. Any other questions? Yes.
For errors, do you need to know like specific?
You won't need to know the exact thing. You can just say it's going to output an error. Okay, it'll output an error. You don't have to tell me error is that it's going to say NA when true false value missing or something like that. Okay, or true false value needed or something. Okay. Okay, today we're talking ggplot. Ggplot is how we do graphics, or one way to do graphics in R. A lot of my stuff is coming from this textbook called R Graphics Cookbook. And you can read the entire textbook on this website here. All right, that's really nice. Or you could buy the print textbook for $60 online. ggplot is a package created by Hadley Wickham, part of the tidyverse. The GG in ggplot stands for Grammar of Graphics. Okay, and that was a system created by Leland Wilkinson. And this system provides a formal and structured perspective on how to describe data graphics. So I'm a huge fan of ggplot, and I highly recommend it, and that's why I'm teaching it. But it's not to say that you have to use ggplot for everything, right? I still use base graphics all the time. Base graphics are quick and easy, and if you just need something simple, like you just need to make a histogram, you just need to make a box plot very quickly, base graphics, probably the way to go, right? But ggplot, if you need to do anything a little bit more complicated, ggplot is quite useful. All right, this is the central idea in the grammar of graphics in ggplot, okay? Is that we map properties of the data to visual properties of the graphic. I'm going to repeat this several times today, okay? This is the central key idea, that we are mapping properties of the data to visual properties of the graphic, right? So assuming your data is tidy, okay, properties of the data are things like your columns. What variables do you have stored in your columns? So you can imagine we have a data set and you have information about the person's height. That's a property of the data. Person's weight, it's another property. Their gender, their race or ethnicity, their hair color. These are all different properties of the data. The visual properties, okay, like if you're making a scatter plot, visual properties that you can map to are things like the X position or the Y position, or the colors of the points, the shapes of the points, I don't know, the size of the points, transparency level, different properties of points, okay? And if you have a graphic that is not mapping data to visual properties, this is not a data visualization, it's just a graphic. All right, so here is just a simple data frame. I've got 6 people. I've got their height, their weight, their gender, their hair. So height is like 62, weight 120, female, brown hair, height 67, weight 140. This is, American units. So 67 inches, 140 pounds, female, black hair, things like that, okay? And I'm going to explain this code later, but this is how we create a graphic. We say, we call the data, we give it a mapping, okay, because that's what we're doing. We're mapping aesthetic attributes. We're mapping data properties to aesthetic attributes, and we're going to say make points out of this. And this is the plot that results, okay? And we can see all the properties in our data are mapped here. So this triangle represents a person whose height is 72 inches. Their weight, it's hard for you guys to see, but the weight is 190, okay? This person, because it's a triangle, has blonde hair, and because it's teal colored, is male, okay? Here's a person, okay? Their height is 68 inches, their weight is 165. They have black hair, okay, because it's a circle, and it's teal, it's male, right? So here's orange color female, black hair, 140 pounds, 66 inches, 67 inches, something like that, okay? So different information. We plot this. And this gets a little philosophical here, but this is the power of a data visualization. This is why data visualization is so great, is that it allows us to use the visual processing abilities of our brain to think about quantities and values, okay? Our brain has the most amazing visual processing system, okay? We just take it for granted, but this is the challenge that is present right now, and kind of AI and data science and all of this, is that we want to get a computer to be able to see. We want it to be able to look and say, this is a chair, this is a table, there's an apple, and this is a person, and this is a car, and it's coming at me, and I should move out of the way, right? Our brains recognize all of this right away, right? Like we can stand and we see a car and we go, okay, that's coming towards me. We have this amazing visual processing system, okay? And when we have a data visualization, we are able to use that ability, okay? If we look at just the numbers in the data frame like this, it's a lot harder for our brains to recognize patterns. If I say, is there a relationship between the numbers in this column and the numbers in this column, you would have a tough time just looking at the numbers and saying yes or no, okay? You would have to kind of sit and think about it, right? If I said you're not allowed to draw any pictures, because drawing pictures is utilizing that part of your brain, if you just have to look at the numbers, it's a lot harder, right? When you see something like this, immediately say, okay, there's positive correlation. You know, as we go to the right, things tend to get larger. As we go to the left, things tend to get smaller. We can immediately see that, whereas looking at these numbers, it's not as easy, right? And that's why, you know, I think in your Stats 10 class, they always say, plot the thing first to see if there's a linear relationship. Why? Because our brain is able to look at dots and say, that looks like a line. Like, we're really good at that. Whereas when we look at numbers, our brains can't do this, right? Because what's going on, it's actually really amazing that your brain is able to attain information from this, right? So when you look at this data, what's going on is your eyes look at this, it sees that shape, and your brain recognizes that symbol, that character, and says, okay, that's a 6, that's a 2. That has this meaning of 62, which is a quantity, okay? And so we are using this symbol recognition, and we create kind of this thing in our brain that says this is a numeric quantity, all right? Or if you look at this page, your eyes look at the stuff and it recognizes the symbols, and it uses the linguistic parts of your brain and says these are words, and we derive meaning from these words, okay? But that, as part of your brain, has a difficult time just recognizing immediate patterns right away. Whereas over here, this uses a different aspect of your brain, kind of this spatial visual thing, and it says, okay, I see a pattern. Things are kind of lining up from left to right, from lower to higher, and things like that, okay? And so that's why we want data visualizations rather than just presenting the data straight up, okay? However, a data visualization in of itself is not useful unless the brain is able to go from the visualization back to the data, okay? Your brain also has to look at the picture and then understand what the data means here, okay? And so there's two parts. The data visualization goes from the properties, it should say properties of the data to a graphic, okay? So it produces from the data, goes to the graphic, and then the visualization has to help the viewer go from the graphic back to the data in the brain, okay? And so that is done via things like the numbers on the side, okay? Now we can say, oh, this thing represents the number 62. This thing represents the number 72. This circle represents black hair. This color represents male, things like that, okay? So those labels and scales are important. We need to be able to go back. Is that all right? Kind of this conceptual idea of data visualization, right? And so, you know, if I gave you this and I said, what was the original data? It's a little bit of a tedious homework, but you could do it, right? You could say, all right, this person, 68 inches, 165 pounds, black hair, male. This person, 65 inches, 160 pounds, blonde hair, female, right? You can go through each of these points and you can figure out exactly what data that point represents, right? And you could go back and recreate this entire table, maybe in a different order, but you could create the entire table, okay? And that's what we need. That's what a good good data visualization will do. It takes the data and presents it visually, and if necessary, the person looking at the visualization is able to recreate the data itself. All right, so some terminology. The data is what we want to visualize. It has variables, and those are stored in columns. Geomes are geometric objects, okay? So far, we've had geometric objects, but you can also have lines or bars or other things, okay? Aesthetics are properties, visual properties of the geometric objects, such as the X position, the Y position, the color of the line, or the shape of the point. Those are aesthetics. And the mapping maps values in the data to aesthetics, okay? Scales are how we control the mapping of the values in the data to values in the aesthetic space, right? So the aesthetic space, as far as the shape of a point goes, you have things like triangles, squares, circles, maybe a star, okay? And how do we go from the values that appear in the data, let's say they're, brown hair, black hair, blonde hair, how do we map those values in the data space to the visual space, right? Or what if your values are 1, 2, 3, 4, 5, and you want to map them to colors? Can that be done? Okay, and you might have to say like, okay, 1 will be represented with black, and 2 will be like a little bit lighter, gray, and 3 will be lighter, and then 5 will be very light or white points or something like that, okay? And so you have to say, well, what can I represent visually as far as colors go? And you might have a gradient or something, and then you can say, okay, well, how do I go from the values in the data space to this color visual space, all right? And then guides, on the other hand, are, now that the values are represented in the visual space, how do we allow the viewer to map it back to the data space in their brain, okay? And so the guides are things like the tick marks and the axis labels and the legends that go off on the side, okay? So again, here's just the code that we've written, okay? It's the same code that I've been using so far. What we say is we're taking the variable height, mapping it to the aesthetic attribute of the X position. We take the weight and we map it to the aesthetic value of the Y position. Gender gets mapped to the aesthetic attribute color. Hair gets mapped to the aesthetic attribute shape, okay? And then we say we're going to represent everything with points, and we say all the points will be size 10. Okay, when we create the plot, we have the scales, and these are determined for us automatically by ggplot. It automatically says the lower bound of the plot is going to be something, like 59.5, 118. In the upper right corner is like 72.5, 192. It automatically chooses the colors. It's like the salmon color and this teal color for the genders, and it chooses the shapes automatically, triangles, squares, circles, things like that. And then it also creates the guides for us automatically. It produces the legend, it produces the things, okay? And so, this is what we end up getting. It produces these legends for us. Okay, what would happen if I change the aesthetic mapping? If instead I decide to map, so over here I have gender mapped to color, and hair color mapped to the shape, okay? And we can see, the teal points are the males, and these salmon orangish colored points are the females. Triangles are blonde hair, circles are black hair, squares are brown hair, okay? What if I switch that and I say hair color goes to the color, gender goes to the shape? How is that going to affect my plot. So what colors will I see? Or what colors, how many colors will I have? I'll have 3 colors, okay? So that's the, and then I will have only 2 shapes, okay? And so now the males are triangles and the females are circles, and then the hair colors, I've got kind of the salmon, the green, and the blue, okay? And we can see those colors represented. It's the same exact information here, but we have swapped how which variable gets mapped to which aesthetic attribute, okay? Here, genders are now shapes, represented with shape, and then the hair color is represented with the color of the dot, okay? And I don't know, which one is preferable, right? Do you think this is better, or is this better? Okay, and the answer depends on what variable is important to you, okay? In general, our eyes will notice color before it notices the shape of the point, okay? So whichever variable is more important, that you think is more important, that one should probably be mapped to color. So if you think gender is more important and you want to be able to say this is the difference between males and females regarding height and weight, then draw attention to the gender by using colors, okay? Whereas over here, if you're trying to show that, you know, if you create this plot and then you say something like, as you can see, there's a difference between males and females, it's a little bit harder because now I have to really focus on, are these circles or are these triangles? And that's kind of a secondary thing for us to notice, okay? I think it's a lot easier to notice the colors, okay? All right, what would happen here? What if I change the mapping and this time I map the hair color to the y-axis? Is that even possible? Hair color, remember, is things like brown hair, blonde hair, and black hair. Can I map that to the y-axis? Okay, and what would happen if I map it to the y-axis? When I get it. Okay, so notice I'm still saying geom point, okay? So the geometries that I'm plotting are still points. And then, and I've also mapped weight to the color. So what would happen to the color there? What would this look like? Okay, so what ends up happening, okay, is that I have 3 positions vertically. I've got a position for black hair, position for blonde hair, and a position for brown hair, okay? So these are the only kind of 3 positions vertically. And then the weight is now represented by this color gradient. It goes from dark blue, almost navy or black, to a light blue color, okay? So the lowest weight is represented by this almost very dark navy, almost a black color, and that's going to be 120. And then the highest weight that we have, 190, is going to be represented by the lightest blue color, okay? And so we can look at this point, and all of the information is still there. We have somebody who's 72 inches tall, looking at the height. The weight, looking at the color scale, is 190. This is the lightest color point I have. We can see that the person is male because it's a triangle, and the hair color is blonde. So I'm still able to go from the visual space back to the data space and recover all of the values. But this graphic is very different from this graphic, okay? And it's a lot harder to kind of reason about, okay? Here, we would use this, okay? So I would say, you know, we would notice the X and Y position first, then the color, then the shape, and that kind of in that order. And so here, you could use this to kind of draw attention to, I don't know, how height differs based on hair color or something like that, okay? And we would say, I don't know, people with black hair tend to be whatever, and people with brown hair tend to have this, and blonde hair, I don't know, you know, something, okay? I only have 6 data points, so it's really hard to draw any kind of conclusions. But anyway, the point is, ggplot is able to take something like the categorical variable of hair color and put it on the y-axis, and it's going to end up looking something like this. We have mapped the data attribute to an aesthetic attribute, right? And so kind of the key here is that representing a number with a y-coordinate, okay, seems very different from representing a number with the color of a point. So here, if we're talking about weight, representing the weight with the y-coordinate feels different from representing that weight based on a color, okay? But at an abstract level, they are the same idea. We are just taking a data attribute and mapping it to a visual attribute. Whether that visual attribute is the y position or the color of the point, it's at an abstract conceptual level, it's the same thing, right? Is that okay? What we're trying to say here? All right, and so if you understand that concept of mapping from columns of the data properties to aesthetic attributes, then everything in ggplot will make sense, okay? Because everything is centered around this aesthetic mapping concept. And if you're struggling with that, kind of just go through and make sure this concept makes sense, because otherwise, we'll struggle a little bit with ggplot, okay? So variable types are going to determine what aesthetics you can use. So if you have something like a categorical variable, certain aesthetics can only work with categorical variables. For example, the shape of a point, right? So the shape of a point, you can represent them with triangles, circles, squares, stars, or something, okay? And it doesn't make sense to try to attach that to a continuous numeric variable like weight, right? So if you have somebody who weighs like 190 pounds and somebody weighs 192 pounds, are they going to have different shapes? You probably can't do that, right? You would have to either take that numeric variable and make it, categorize it and say like people under a certain weight, people between here and here, and people over a certain weight or something, right? You're like categorizing, then you can put them into shapes or something, but you can't, I don't know, right? If you did like one shape per number, you'd end up having like 200 shapes that you'd have to use. And I can't even think of 200 shapes, right? I think there's a package that you can use with ggplot called ggEmoji or something, and that allows you to use like emoji symbols to plot onto a ggplot, and you can, I don't know, plot little cucumbers and dog faces or something, but I don't know if that's a good idea or not, right? It's fine. I guess if you wanted to do something about fruits and you have categories and you wanted to show the pineapples, you can do that. Okay, but anyway, other aesthetics like the X or Y position, even the color we saw can be categorical or continuous and things like that, right? So think about that when you're making plots. Okay, just a quick note about ggplot versus base graphics. All right, you can do a lot of stuff with base graphics, but it's going to be a little bit more work. Okay, and so if I wanted to do something similar, I would have to create a vector for the colors and a vector for the shapes that I'm going to do. And so these are some of the lines that I've done. We call the plot, and we map the vector of colors and the vector of shapes to these, the color and the plotting character and things like that. And I don't know if you've ever tried to add a legend to an R plot, okay? But it's not fun, okay? It's not fun making a legend in R. So I mean, you can do it, all right? But with ggplot, it's a lot easier, I think, in my opinion. You just kind of do the aesthetic mappings, right? Which by now we conceptually understand, I hope, how the aesthetic mapping goes, and then ggplot handles the rest. It creates the legends for us. It creates the scales and all of that, okay, which is really, really nice. Okay, so to kind of get into it a little bit more, I'm going to just kind of start from scratch. So here's our data frame. And first, if we call ggplot on this, here I'm just mapping height to x and weight to y. And this one has no geometric objects, and so it just creates this blank plot. Okay, but it's already produced a scale for us. It says, well, it looked at the lowest value for height and the maximum value for height, and it creates kind of our x and y x limits. And then it looks at the smallest and highest values of weight, and it creates our y limits as well. All right. If we want to add points, we can call geomepoint, right? So we're going to do ggplot plus geomepoint, and it plots these dots here, okay? And here, because I've only mapped 2 attributes, there's only 2 attributes to be mapped here. So we don't have anything information about the gender or the hair color. That doesn't appear here because they haven't been mapped. There's nothing to represent this, right? A thing about ggplot is that you produce graph objects, and so you can actually store this thing as p, and then you can call p plus geomepoint, and it'll produce this plot. This plot here I could have just stored as this, okay? And then now I'm going to specify color is equal to gender here, okay? So you give it color, the grouping variable or whatever. And so because it goes inside AES, this is going to be an aesthetic mapping. We're going to now plot the gender, represent the gender using the color attribute here, okay? And so here's the plot, okay? And so we get the salmon points and then the teal points. And again, these points are tiny here, okay? But this is an aesthetic mapping. Now we've represented gender and it's being mapped to the color there, okay? You can change things, right? And here, this is called settings, okay? Settings do not go inside AES. Settings are just settings, okay? So here I'm going to say color is equal to blue. And what this will do is it's going to set all of the points will be represented with blue dots, okay? So because everything is represented with the same color, color is not meaningful in terms of it doesn't represent any kind of variable, okay? So the fact that it's blue doesn't represent a variable. I'm also setting the size to be 10, and the size does not mean any variable either, okay? So here there's only 2 variables being represented, the height and the weight, okay? But the color doesn't tell us anything about each person, and the size of the point doesn't tell us because they're not being mapped to a variable. They're just set. They're set for everybody. You can change the scale, okay? So scale, right now, it defaults to looking for the min and the max, and it sets the scale that way. But if you wanted your visual space to have a larger scale for whatever reason, okay, to kind of emphasize some point that you're trying to make, you can do that. So here you're going to set the limits from 60 to 100, and this is going to be the limits of my x scale, and so now it goes from 60 off to 100, okay? You can do other things like the color scale. You can set the color scale. So by default, it picks kind of the salmon and teal colors for 2 categories. You can say, I want orange and green, or forest green, I guess, okay? And I'm going to map gender to color, okay? So notice what I'm doing here. Gender is going to be mapped to color, so that goes inside the aesthetic mapping AES. Here, 10 is set for size. Size is set to 10, so this is a setting for all of the points. So all the points will get a size of 10, but the points will have different colors based on their gender, okay? And then I'm setting the scale for the color using orange and forest green. And so this is what I get, okay? So now I have males and females represented, their heights and weights, and we have nothing about hair color that's not on here. Okay, one thing is that ggplot, when you produce a plot, it doesn't automatically print, so you might have to call print, especially if you're running it inside of a loop or something like that, or a function. You might have to call print on the plot that's being produced, and so that's just something to think about. And other things, we kind of take certain plots for granted, but there's actually work to be done to produce a plot. So if you're going to make a box plot or a histogram, R actually has to figure out where the quartiles are, or it has to bin the values into different bins, and so thankfully ggplot includes some of these things for us. geom_histogram that will do all of these operations for you, but we're not doing that. Okay, I'm going to just kind of flip through this last section very quickly, and these are just about different geometries and how we can create different plots. Okay. And so your basic geometries that you're going to be using probably most often will be points, lines, and bar plots, okay? But there's a ton of other geometries, right? You can have histograms and box plots, and you can click this, this link here, and this will take you to kind of a list of all the different geometries, all right? There's all sorts of different things. You can click this cheat sheet, and it shows you a bunch of different geometries that you can use as well, okay? And it will tell you what the different aesthetic attributes are that you can change. So you can change the X and the Y, the alpha, the color, the fill, the shape, the size, and the stroke, okay? So these are all different aesthetic things. I think so far I've just been using X, Y, color, and shape, but these are any of these other things can be mapped to some variable. Okay, so these are all, and so all of these things include just different geometries that you can create here. Okay, so explore that. Okay, so let's just talk bar graphs. I'm going to just kind of flip through this very fast, but they're all just the idea of you map something to something. Okay, so here you might have a summary table already, and you've got one variable for the X position, and then here this column represents how tall you want your bars. Okay, because the values themselves are how tall you want the bars, you're going to say stat is equal to identity, and it creates this plot for us. Okay. Here's another one. I've got 3 dates, day 16, day 20, day 21, and I've got 2 cultivars, cultivar 39, cultivar 52, and we want to plot the weight. Okay, so we're going to map the X to the date, so we're going to have 3 X positions. Y is going to be the weight, that's going to be the height of the bar, and the fill, the color of the bar, will be based on the cultivar. Okay, because Y, the height of the bar, is going to be based on the value here, we're going to say stat equals identity, and we create a plot that looks like this. A bigger data set with diamonds, it's got something like 53,000 rows in it. Here, if I take a look at the variable cut, okay, the default behavior, if I don't put in something like stat equals identity, the default behavior is to take a categorical variable, create a table of counts, and create a bar plot based on those counts. So it's going to say this is how many ideal cut diamonds I found, how many premium cut diamonds I found, and stuff like that. So that's kind of the default behavior of geom_bar. Here I've got some variable information about states. This is their abbreviation, the region, are they in the west or the south or some other place, and this is how much their population changed, right? So Nevada grew by 35% between the 2000 and 2010 census, and we're going to look at the 2020 census, and it probably grew even more. And so that it gets 35%, and so we can plot this. So fill is mapped to the region, so we get the west versus the south. Here I'm mapping both the Y and fill to the change. So this shows the same information that the tallest bar is also the lightest color bar. The shortest bar is also the darkest color bar because change is being mapped there. You can do things. You can rearrange the bars. You can reorder them. You can reorder the abbreviation variable based on the change, and it does something like this. Okay. You can change the manual colors manually, and this uses our school colors and stuff. If you wanted to do something like have a continuous variable, you can set the gradient colors from low to high, right? So it goes from red to blue, and you get some kind of gradient here. Because there's just a huge jump here, you don't get the colors that are in between. Okay. As far as line graphs go, okay, basic, you can just do X and Y, and you get a line plot like this. Here I've got your X and Y position, but we've got two variables. We've got orange juice and I think vitamin C or something. These are some categorical variable. And so different, as far as lines go, different aesthetic attributes is the color of the line, okay? Or if you're dealing with a black and white printer situation, you can change the line type and you'll have a solid line versus dotted line, okay? And again, all of this stuff you can look at some of these options here. Where are they? Okay, I don't know. Okay, too much. Here we go. Okay, so as far as the line goes, you can change, the alpha, the color, the line type, group size, stuff like that. Okay. And then we've looked at scatter plots, and I think we've already done all of these things. But you can change the shape, the size of the points, the color of the points, the shape of the points. Okay. Obviously, color is a lot easier. It's easier to see the blue and the red dots than it is to see triangles and circles here. Okay, right? These just all look like little black dots here. Okay. And then if you wanted to combine data from multiple data frames, okay, which is sometimes something you need to do, you can do that, right? So you call ggplot on some original data. Okay, so here this original data contains information about plotting the sine graph here, sine curve. And then here, so this I've done the original data with geom line. And what I'm going to do is I'm going to add point geometries. But inside my call for geom point, I call data is equal to a new data frame points. Okay, so you can add additional geometries using a different data frame, and it's going to do it. Okay, so here are different values here. The points get added. All right, and here now I have another entire data frame segments. Okay, and I'm going to add segment geometries, which are little pieces of lines. Okay, and these are just generated randomly, so there's no meaning here to them. Okay, and I can just add that. So this plot's a mess, but the idea is I've got 3 different data frames, and I'm plotting stuff from each of those data frames, because sometimes you want one plot that's including information from different data frame sources, and you can do that just by adding the geometry that you're doing, but you specify the data there. Okay, and then you specify your aesthetic mappings there as well. Okay, so ggplot is quite powerful, allowing you to do stuff like this, and you can always just go to the reference things. There's other stuff like themes that will do just kind of change the colors to black and white, or whatever themes you want that pick certain color schemes and stuff for you. So it's quite nice. All right, we'll end here for today. Have a good weekend. Please get started on your homework, and I'll also post up an old midterm for you guys to look at and practice from. All right, we'll see you guys next week.